In the South Bethlehem Forge shop in 1892, the hydraulic armor plate press did not announce itself. The steam hammers could be heard through the ground a quarter-mile away, felt through the boots of steel workers across the floor. But the massive forge press made almost no sound. Thousands of tons of force descended in one slow, continuous motion through its hydraulic ram, making no noise until the red, hot steel yielded beneath it. The silence was the machine's signature. That silence was the most dangerous thing in the building, and the steel it squeezed would go on warships that fought America's first modern naval war. If you are new to Steel and Sweat, this channel covers the machines and the men of American industrial history. Subscribe now and leave a comment with the next story you want us to dig into. There is a specific quality to a machine that operates by continuous force rather than repeated impact, and it is something the steel workers on the Bethlehem Forge press floor understood in a way that the rest of the plant never quite had to. The steam hammer announced every blow. The sound and the movement told you what the machine was doing, and if the sound changed, you moved. The forge press had no such signal system. The force it applied was not a series of events you could track and react to. It was one event, sustained, building on itself. And by the time anything in the hydraulic system indicated a problem, the sequence was already past the point where moving would help. This was the paradox of the Bethlehem Steel forge press. It was the most controlled forging machine on the floor, and the one that gave the mill workers beside it the least warning. But to understand how a machine that large came to exist in South Bethlehem in 1892, you have to start with the problem it was built to solve. By the late 1880s, the American steel industry was producing more than 3 million tons of steel per year, its Pittsburgh mills and Pennsylvania furnaces feeding a construction boom that stretched from railroad bridges to urban skyscrapers. In the middle of that industrial expansion, the United States Navy was designing its first modern steel battleships at naval shipyards in Newport News, Virginia, and Mare Island, California, and those ships needed armor plate that could stop a hardened artillery shell fired at close combat velocity. American steel mills had been making armor plate for years, but the armor they were producing had a fundamental problem. The harder you made steel, the more brittle it became under impact. The tougher you made it, the softer the surface and the easier for a shell to penetrate. Getting both properties into the same plate, a hard outer surface that stopped penetration, and a tough steel backing that absorbed the energy, required a specific process and a specific machine. The machine was the hydraulic forge press. Carnegie Steel in Pittsburgh had the volume, but the only steel mill in America with the forge capacity and the hydraulic press large enough to run the armor plate process was Bethlehem Steel in South Bethlehem, Pennsylvania. Could you imagine being handed that contract in 1890? The Navy needs armor for warships. You have to build a machine with no precedent in American manufacturing to produce it. Leave a comment below with what you think that engineering challenge actually looked like. The Bethlehem Steel hydraulic forge press, when fully assembled in the early 1890s, was the largest forging machine in America. The massive steel frame rose from the Bethlehem plant floor to a height that made the overhead cranes and the steel workers moving below look small. The operator's platform, where the man who controlled the press valves stood and worked, looked down on the entire forge bay from above. The frame columns and crossheads that guided the hydraulic ram were themselves huge forged steel sections, assembled by ironworkers who had produced them in the same Bethlehem Steel hammer shop that would work alongside the forge press for the next several decades. But the first work on the forge press was not assembly. It was excavation. Before any part of the machine arrived at the Bethlehem plant, construction crews with steam-powered equipment dug into the bedrock beneath the forge shop floor to pour a concrete foundation of a depth and mass that had no other purpose in the world except to hold this machine. Some heavy press installations of this scale went 30 feet below grade. The concrete and the bedrock together were not carrying the weight of the forge press alone. They were carrying the weight of the forge press, plus the full load of whatever the press was pushing against, which pushed back with equal force. The foundation was the machine's counterpart, and it had to be right, or nothing above it would work correctly. When the Bethlehem Steel forge press was commissioned, and the massive industrial building had been modified around it, the relationship between the structure and the machine was permanent in a way that no other piece of equipment in the plant was permanent. A steam hammer could, in principle, be dismantled and moved to another steel mill. The forge press could not. The building had been arranged around it. The overhead cranes had been specified to service it. The walls had been built to clear it. Once the press was set and the hydraulic accumulators were charged and the first production cycle ran, the forge press was the building in every functional sense that mattered. Everything else on the Bethlehem property was arranged in relation to where the machine stood, and where it stood was where it would remain. That permanence was not a choice. It was a physical fact, and the steelworkers who worked the Bethlehem forge press floor for decades understood it as part of the context of the job. The machine would outlast them. The press would outlast the Navy contracts and the production schedules. They were going into an industrial building that had been built for a machine, and when their working lives were done, the machine would still be there. By the time a production run was active, the Bethlehem Steel forge press had already been running for hours. The accumulator system, a bank of large hydraulic cylinders that stored water under pressure between forging cycles, was charged and holding. The pump systems that maintained that pressure ran continuously during production, producing the low background hum that was the constant sound of the forge bay. That sound was the sound of energy stored and waiting, not the energy of motion, the energy of hydraulic pressure held inside sealed cylinders, ready to be directed through the main ram the moment the operator opened the valve. The operator stood on an elevated platform above the Bethlehem Steel forge shop floor, one man at a set of valve controls on the upper level of the press bay, looking down on the steelworkers below and across the full bay of industrial machinery. The forging machine under his hands was capable of applying thousands of tons of force to the red-hot steel plate positioned on the press bed, but the valve itself required almost no physical effort to open. The force did not live in the operator's hands. It lived in the hydraulic accumulator. The operator's job was to direct it, to control the rate of descent, to read the steel and the machine together and make the adjustments that a particular heat and a particular armor plate required. The knowledge that made a press operator worth keeping on the Bethlehem Steel floor was not physical. It was the ability to read a hydraulic system that gave almost no feedback through the controls. That was the unsettling part of the job, and the part that took years to develop. A steam hammer operator in a steel mill felt the machine in his body. The impact was transmitted through everything in contact with the forge floor, and a hammer that was behaving differently than usual announced that difference through sound and vibration. The forge press operator felt almost nothing through the valve. The system was sealed. The force moved through pressurized fluid, and the signs that something was developing in the hydraulic lines were subtle and required the kind of attention that only experience could build. But the operator was not the man closest to the danger. The steel workers closest to the danger were the floor crew inside the die gap. The die gap was the space between the upper die face attached to the descending ram and the lower die face set into the press bed. At full open, that gap was large enough for steel workers to position a red-hot steel plate blank that might weigh several tons. Forge workers handled these heavy, glowing steel blanks with iron tongs and overhead crane rigging. They worked inside that gap by hand signal, reading the operator's gestures from across the forge bay, because the ambient noise from the surrounding Bethlehem Steel plant made verbal communication unreliable. Their job was to position the blank on the press bed and clear the gap before the operator closed the valve. The sequence in, position, signal, clear ran on timing built from months of working together. It ran that way every single cycle, every shift, every production run. The routine was safe because it was precise. But precision under pressure erodes in ways that are hard to track, and the hydraulic forge press did not forgive imprecision the way a steam hammer did. A steam hammer stroke in a steel mill was finished in a fraction of a second and lifted on its own return cycle. If something went wrong between the dies, the aftermath of a hammer blow was at least bounded by the next lifting cycle. The forge press came down in a continuous motion and did not lift until the forging cycle was complete. Once it started closing, the sequence ran to its end. The steel workers on the Bethlehem press floor knew this. Every man who stayed on the forge floor long enough to be trusted in the die gap knew exactly what the machine was capable of, and exactly what the margin was between a normal cycle and a cycle that went wrong. They knew it, and they came back the next shift. And they did it again because the alternative was not working at Bethlehem Steel. Working there paid better than anywhere else in the Lehigh Valley, and the mill workers who were good enough at the job to be trusted with it took a specific kind of pride in that. Could you imagine doing that for 30 years, working inside a massive industrial forging machine, learning to read its hydraulic behavior through hand signals and floor vibration, building a career on the precision of your own timing? The press operators and the floor crew at Bethlehem Steel were not interchangeable with the general labor pool, and both sides of that arrangement understood it. The Bethlehem Steel plant needed men who could run the forge press correctly because there was no other steel mill in America capable of filling the Navy contract. The men needed the wages the press floor paid, wages that drew skilled steel workers to the South Bethlehem plant from across Pennsylvania and from the immigrant communities in the steel towns of the Lehigh Valley. But beyond the economics of it, there was something else. The men who worked the Bethlehem forge press floor for years developed a relationship with the machine built on accumulated knowledge of its specific behavior. The way the hydraulic accumulator pressure felt at different points in the production cycle, the way the red-hot steel responded under the ram at different temperatures, the way the forge shop floor vibrated when the loads were distributed correctly. That knowledge did not come from training, it came from time. The most experienced press operators and floor crew at Bethlehem Steel were men who had started in the early 1890s when the forge press was new and everyone in the plant was learning together. By the time USS Oregon's armor plate was being produced, those steel workers had years of that knowledge behind them, and the plates they were running had a destination they would never know. If you are finding this history as important as anything we have covered on this channel, go ahead and hit subscribe right now and leave a comment below with what you want to see next. The Bethlehem Steel plant ran on 12-hour shifts with no Sundays and no breaks between production runs. Men came in before dawn and left after dark for months without a day off. And the forge shop floor ran at temperature around the clock because the heating furnaces could not be cycled down between shifts without losing hours to reheating. There is a specific kind of fatigue that builds on a forge press floor over a 12-hour shift in a steel plant like that, and it is not primarily physical. The work was not hard in the way that the steam hammer floor work was hard. The hammermen in any steel mill managed impact, and their bodies absorbed the secondary shock through the floor and the tong handles, and by the end of a shift, they were spent in the way that sustained physical shock leaves a man spent. The Bethlehem forge press floor was quieter, and the direct physical demands on the floor crew were focused on a small number of critical moments per cycle rather than a continuous grind. The attention required to work inside the forge die gap was of a different kind. It did not relax between cycles. Steel workers in the die gap managed proximity to a force they could not track by sound or sensation the way hammermen tracked the hammer. They read the operator, they read each other, they read the position of the red-hot steel blank, the state of the hydraulic system, and the feel of temperature through the iron tong handles. They did all of that simultaneously, and they converted it into the hand signals and timing decisions that kept the forging cycle moving without anyone getting hurt. The press operators who ran the Bethlehem Steel Armor Forge in the 1890s developed a skill set that had no formal curriculum. There was no written procedure for running the hydraulic forge press. There was no training program at the steel plant. What existed was the accumulated experience of the men who had been there longest, transmitted to men learning by working alongside them in the specific language of a forge shop where verbal communication was unreliable and where what passed between steel workers was mostly gestural and observational. A new floor crew member learned by watching, by doing the lower stakes parts of the job first, and by working in the forge die gap with experienced men who could compensate for the judgments a new man had not yet developed. That specificity was part of what kept steelworkers on the Bethlehem Forge press floor for their entire working lives. The embodied knowledge of this specific hydraulic machine on this specific steel mill floor was the anchor, a press operator who had spent 10 years on the Bethlehem floor reading the accumulator pressure, the valve response, and the behavior of the hydraulic ram at different load conditions, could not take that knowledge to a different forge press in a different steel plant and expect it to transfer. The Bethlehem machine had its own character, built from its specific hydraulic design, its specific foundation, and the decades of incremental adjustment that operators and maintenance workers had made to it. The men carried knowledge inseparable from the machine itself, and that made moving on a choice with a real cost. The armor plate schedule for the Indiana-class battleships was one of the pacing factors in their construction, because the Bethlehem Steel forge press and the heat treatment furnaces alongside it could only produce so much plate per month. The naval shipyards could not install plate they had not received. The battleship construction sequence waited on South Bethlehem, and the Bethlehem Steel plant ran the forge press to meet that schedule, and the steelworkers on the press floor were the last human hands the steel passed through before it was loaded onto Pennsylvania Railroad freight cars and shipped east. That connection between the Bethlehem Steel forge shop and the naval shipyards in Newport News and Mare Island was not visible in the press bay. The floor crew did not work with a mental image of the battleship hull waiting for the plate they were producing. They worked with the red-hot steel blank in front of them, the cycle they were on, the signals from the operator above, the weight of the iron tongs, and the feel of the forge shop floor through their boots. The destination was in the contract paperwork, not the work itself, but it was there. The armor plate that left the Bethlehem Steel plant in 1892 and 1893 went to naval shipyards on both coasts at Newport News Shipbuilding and Dry Dock Company in Virginia, workers at one of the largest and best documented shipbuilding facilities in America, lifted the Bethlehem plate sections with overhead cranes and fitted them into the hulls and gun turrets of 3 pre-dreadnought battleships under construction for the United States Navy. USS Indiana, USS Massachusetts, and USS Oregon were the first modern American battleships, and the armor belt at each warship's waterline, the plate protecting the gun turrets, the protection around the engine spaces and the magazine, all of it had been forged under the Bethlehem Steel hydraulic press, worked by steel workers who would never see the warships and would never know what those ships were asked to do. USS Oregon was commissioned at the Puget Sound Navy Yard in July 1896, her steel hull and armored turrets completed, and she was assigned to the Pacific Station. She operated there for 2 years on peacetime deployment, and the steel workers at the Bethlehem Steel plant who had forged her armor were on other contracts. The forge press was running plate for other ships. The connection between the South Bethlehem Forge shop floor and the warship operating in Pacific waters was not something that showed up in production records or shift reports. They had forged a product to a specification, and the product had been delivered, and that was the end of the visible line. In April 1898, a nation whose steel mills were producing 10 million tons annually and whose shipyards had just delivered its first modern battle fleet, declared war on Spain following the explosion of USS Maine in Havana Harbor. Oregon was at San Francisco, and the Navy needed her on the Atlantic side. She was ordered around Cape Horn. She left San Francisco on March 19, 1898, and she sailed 14,000 miles south through Pacific Ocean swells, down the South American coast and around the windswept, storm-lashed tip of the continent at Cape Horn and north up the Atlantic coast to Key West, arriving on May 24th after 66 days at sea. No mechanical failures, no casualties, every gauge in her engine spaces reading normal, every armor plate on her hull and turrets holding exactly as the Navy's contract specification had required. A warship built to cross oceans, doing exactly that. On July 3, 1898, the Spanish Atlantic Squadron under Admiral Cervera attempted to break out of Santiago de Cuba harbor. The American fleet was waiting. The naval engagement lasted several hours. Oregon was in the American line throughout the battle. The warship sustained hits from Spanish naval guns. The The forged armor plate on her hull and turrets held. The steelworkers who had forged that armor were at work that day, not at Santiago de Cuba, but in South Bethlehem on the forge press floor at the Bethlehem Steel plant, running production on whatever contract was current. They would have read about the battle in the newspaper days later, the way a man reads about something he has no direct connection to. There was no connection they could trace between the valve controls they had worked and the armor plate that had absorbed Spanish shells in Cuban waters. The production record that could have drawn that line existed somewhere in the Bethlehem Steel accounting files, but it was not the kind of thing that traveled to the forge shop floor. But the armor held. That was the result of the work, even if the steel workers who did the work never knew it was the result. There is something specific about that outcome that the production records cannot convey. The men who ran the Bethlehem Steel forge press floor in 1892 were solving an immediate problem. Produce armor plate to specification, on schedule, with the machine and the knowledge they had. The armor plate was the product. The battleship was the Navy's concern. The battle had not happened yet. But between the forge shop floor and the naval engagement at Santiago de Cuba, the work traveled through 6 years of peacetime service and a 14,000-mile emergency voyage, and into the most significant naval battle in American history since the Civil War. The properties the steelworkers had forged into the plate, the structure, the density, and the resistance to penetration were present at all of those stages, unchanged, carrying forward from the production run in South Bethlehem to the engagement in Cuban waters. The Bethlehem Steel Forge pressmen produced those properties. The properties held. The American steel industry that built those ships employed 270,000 workers at its 1890s peak, men in Pittsburgh rolling mills, Pennsylvania forge shops, and Appalachian coal mines. And their combined output made the United States the largest steel producer in the world by 1900. When Bethlehem Steel eventually closed and the South Bethlehem industrial site was sold and the forge shop was demolished, the massive hydraulic press was still there. The concrete foundation poured into Pennsylvania bedrock in the early 1890s was still there too, still carrying the machine it had been built to carry. The former Bethlehem Steel industrial site in South Bethlehem, Pennsylvania, where the old forge shop and open hearth furnaces once operated around the clock, is now a casino resort. The hydraulic forge press is still there, anchored to the same bedrock, in the same position it has occupied for over a century. Some of the steel workers who worked alongside it are buried in cemeteries a few miles from the old plant. The forge press is closer to the surface than they are. USS Oregon was scrapped in 1956, 60 years after the Bethlehem steelworkers had forged the armor that carried her through the battle. The hydraulic armor plate press at Bethlehem never moved. The ships it armored sailed the world and fought a war. If you want to keep following the stories of the machines and the men who built the country, subscribe to Steel and Sweat.